Yeah, good evening, Hari sir. So, okay, I think you are listening to me, maybe others also. Fine. So, I am starting with today's agenda, today's session. I think it is I'm going to talk about the chi-square test. So, before starting and talking about chi-square test, can anyone tell me that, yeah, good evening, Toshi ma'am. So, can anyone tell me what do you mean by term hypothesis? Yes. Hello. What is hypothesis? Friends, I hope you are listening to me. Anyone who can tell me what do you mean by hypothesis? Have you people have heard about hypothesis priorly or not? Or whether first time you are going through this particular concept? Yes. Hypothesis which has, just a minute, someone has written. Okay, hypothesis which has been assumed till it gets quantified or justified with proofs. Yes, very correct. Thank you, Deepak sir. So people can read in the chat what sir has written. Yes, hypothesis is what I think sir has written it correctly. I'm just sharing my screen and write according to me what null hypothesis is. Okay, so I'm sharing my screen. I want your confirmation whether it is visible or not. Is it visible? Friends, my screen is visible. Is it visible? Hello? Hello?
Yes, yes.
Okay. Thing is that I got confused because I'm getting some error message. So I thought, I don't know whether you're listening to me. Fine. If you are there, you are listening to me, you can see my screen. I'm starting with today's agenda. Something is wrong today. Am I audible to everyone? Thank you, Asna ma'am. Okay, so I'm sharing my screen again. Just a minute. Fine. So I have written it's day 6. I'm going to talk about hypothesis test. So hypothesis testing is a part of inferential statistics. So inferential statistics is what? Inferential statistics means using this statistic we want to infer population parameters using sample statistic. Meaning is that using the sample characteristics, I want to infer the population characteristics, right? Means if I'm saying this is the population mean or this is the sample mean, so whatever the sample mean is, whether the population mean is same or not, this is what I want to infer. So this is known as inferential statistics, right? So in this we are using hypothesis. So hypothesis is what? It is tentative assumption, or you can say conclusion, right? Which is yet to test or prove, right? So it is very much like in mathematics. I think we have studied the theorems, and usually in maths we are proving them. Similarly, in statistics we are having hypotheses. These are the tentative assumptions or conclusion which we are making, maybe on the basis of our own experience or our observation, or maybe using the past literature. We can making certain statements. So hypothesis is an statement. Hypothesis is a statement which is generally not means which has which you have not tested yet. So right. So untested or non-tested, not non-tested, untested statement you are making, and you want to test it, right? So hypothesis is a hypothetical statement or assumption which you want to test, right? Usually we can say there is null hypothesis and there is alternative hypothesis. Null meaning is generally it is H naught, and alternative is generally H1 or H3, right? So this way we are representing the null and alternative hypothesis. Now null hypothesis is what? It is a statement which is for no difference relation or no impact. Between variables, generally we can say. So hypothesis is made up of your variables, and in variables we want to see whether there is a difference, whether there is a relation, whether there is an impact of one on other. So that way null hypothesis is not accepting this. So this is nothing but this is void. Null is void, means something like this is not existing, I can see. Alternative is what? Alternative is the opposite to the null. So if your data is supporting null hypothesis, you will go to conclude your null hypothesis. But if data is not supporting null hypothesis, you will go with the alternative hypothesis, which will be opposite to your null hypothesis. Till here I am clear what I said? Yes, am I clear? Friends, it is clear? Shall I go ahead? Okay, maybe I'm assuming I can go ahead, right? Yeah, thank you, sir. So you can see I have just discussed the concept of inferential statistics, and inside this we have discussed the term hypothesis, and there are generally two hypotheses we are using, that is null and alternative hypothesis. Now there is a concept of level of significance. So what is level of significance? Level of significance is generally alpha. That is the type 1 error, you can say. So we can say alpha is what? We can say it is probability of rejecting a true null hypothesis. Right? Usually the level of significance, that is LOS, we are keeping as either 1% or 5% or 10%. So that is how much percent error or how much percent error is there in your conclusion which you are committing, it can be generally 1, 5, and 10. So we know if I'm saying 1%, you are in a dilemma whether whatever you concluded is correct or not. That means reliability percent is 99. That is confidence level, right? Similarly, if you are percent delivery you are concluding, so confidence level will be 10%. 10% means it is 90%. Confident you are about your assumption or about your conclusion. So meaning is that if this percent is higher, reliability in your conclusion is less, right? So that is why you need to decide upon what will be the level of significance value. Then I think I already told you confidence level. So confidence level is what? It is nothing but it is 1 minus level of significance, or 1 minus alpha is the confidence level, right? Then we can talk about how to test the hypothesis. So we are testing the hypothesis using the various statistical tests. These tests can be parametric and non-parametric. So when I say parametric, I think I'm not discussing today. We will discuss parametric tomorrow or day after tomorrow. Today, as we need to discuss chi-square test, so I'm talking about non-parametric test. So what is non-parametric test? Non-parametric tests are generally the tests which does not consider the population parameter. This test does not consider population parameter, and that is why we can say do not or does not consider the normal distribution. So non-parametric tests are the tests which is not bothering about the normal distribution of the data, and also these are not considering the population parameter, right? These are based on categorical data. Right? So usually for the categorical data, we are performing non-parametric test. Apart from this, there is one more thing. If your data is not following, suppose you are having numeric data and your variable is not following normal distribution, in that case also we can switch from parametric test to the non-parametric test. So I can say usually we are going for non-parametric when we are having categorical data, but if I'm having numeric data, in that case, firstly, I can go for the parametric test. If assumptions of parametric tests are not meeting by my data, I need to go for the non-parametric test, right? Is it clear? Okay. So when I'm having categorical data, that means I need to have only the count, because in case of categorical data, there is a possibility of count. Count meaning is you can have the frequency, right? Say for example, if I'm saying gender is a categorical variable, so in the case of gender, can I measure gender? Measuring of gender is not possible, but respondent, I can divide them in on the basis of their gender, male, female, and that way I can count how many of them are male and how many of them are female, right? So this way we can understand the categorical data can only lead to the counting of it, or it will only give us the frequency. Is it okay? Clear? Friends, it is fine. Fine. Thank you so much, Deepak sir, being little interactive. Thank you for that. Fine. So that way I can say this is about the non-parametric test. In statistics, there are various tests available which are known as or coming in the category of non-parametric tests like chi-square, Whitney, U-test, Kruskal-Wallis as sign rank test, Wilcoxon test. There are so many different tests available under the category of non-parametric test. Today is the agenda is about chi-square test. So anyone who is having idea, what do you understand by chi-square test? Anyone knows about this? Yes. Anyone? What is chi-square test? Fine. When I say chi-square test, I can say chi-square test is non-parametric because it is not considering the normal distribution of the data. Also, it is based on the categorical data. And the purpose is here we are, or we can say this thing, the purpose of chi-square test is generally to compare observed and expected frequencies. Or I can say the other purpose is to see the uniform distribution. Frequencies. So this is the purpose of chi-square test, right? Then there is a types of chi-square test. So first type is chi-square goodness of fit. Second one is chi-square independence of attributes, or you can call it as test of association, right? So these are the two types of chi-square test. Okay, it is clear? It is chi-square goodness of chi-square independence of attributes, right? I'll explain you the both, and then we'll see performs the chi-square goodness of fit. Chi-square goodness of fit we are using to compare observed and expected frequencies. That means I'm interested here to see the uniform distribution of frequencies. of caste, goodness of it. The case of goodness of fit, we will be having one categorical variable, and here there can be reading interest of the people for magazines. This kind of magazines people are reading, right? So maybe it can be uh, business magazine, can be sports magazine, right? It can be some fun kind of magazine. It can be some maybe Bollywood or entertainment related magazine, etc. Right? So I am I want reading interest, but here I'm counting that how many of the people are reading the business magazine, sports magazine, fun magazine, or entertainment related magazine, right? So in this case, I am having this variable and it is having four categories: business, sports, fun, and entertainment, right? So it is one of the categorical variable. And I'm having the count. So that is what is the in observed and expected frequency. Right? Means something you are observing, that will be observed frequency, and you are comparing that frequency with the expected frequency. So you want to see whether the same example. This is the example, suppose, right? Uniformly distributed or not. So suppose I am using the suppose I'm assuming business type, right? 20 people, right? Was read by 27 people, and then entertainment is read by suppose 40 people. So this way you according to this approach, if you will find your p-value is this and your level of significance, suppose I told you need to test this hypothesis at 5%, you can compare both. Now you can clearly see your p-value is less than your level of significance. So that means I should adopt this line. That means I will reject my null hypothesis. And if I'm rejecting my null hypothesis, so I forgot to write the null hypothesis. I can write the null hypothesis here. There is no significant difference in observed and expected count of color preference. This is my null hypothesis. So according to my data, I should not accept my null hypothesis. That means I should go with the alternative hypothesis. So what I'll say there is a significant difference in observed and expected count of color preference. That means color preference is not uniformly distributed. This is the meaning. This is my conclusion. I can write my conclusion here. Color preference is not uniformly distributed. Done? Clear?
Please explain the conclusion once again.
Okay, fine. I said I'm not accepting my null hypothesis. I am rejecting it, right? So once you are rejecting your null hypothesis, you need to conclude alternative hypothesis. Means I need to go with the alternative. Although I have not written the alternative hypothesis, just a minute. So what I am doing, I am writing the alternative hypothesis also, which says there is a significant difference in observed and expected count of color preference. Means color preference is not same for the observed and expected count. So meaning is that when the color preference is not same for observed and expected, what I can say the color preference is not uniformly distributed, because this is observed figure, right? If I will calculate its expected value in terms of numbers, what will that expected count is what? It is average. So it is, I think it is total 100. 100 divided by 5, which is 20, will be the expected count. So that means for every category, for every color category, I should get the count as 20, 20, 20. That means 20 people should liking the black color, 20 people should liking the white color. This is what we are expecting. We are expecting the count should be same for all the color preferences. But we are concluding there is a difference. That means I can say the color preference is not uniformly distributed. I hope you got it, Hari sir, now.
Yes, ma'am.
Fine. So this is about a very simple kind of chi-square test, meaning using your vector also you can perform this. But what if you are having the Excel file available with you? So I think I'll go and explain you now to import the Excel file into the this R platform. But thing is, the file which I have provided you, it is not the Excel file. If any one of you have seen the file, can anyone tell me what is the extension of the file? Which file I have provided to you? Anyone?
Yes, ma'am.
What is the file? What is the syntax extension of the file? Anyone who can see, tell me.
Education dog owner.
Okay, education dog owner, and extension of the file is what? So it is the name of the file. Extension is for XLS, the extension is XLSX. For the file which I have given you, anyone who can tell me what is the extension of the file? It is .csv file, comma separated file I have given you. Okay, Fine.
Yes, ma'am. CSV file.
Yeah. So CSV file I have given you. So firstly, what you need to do, if you want to import your data, I'll tell you on the two ways. There are two ways of importing data in the Excel, in the R. I'll tell you both the ways, right? I think second one is more easier, but still I'll tell you both the ways. First one is, firstly, you need to set your directory from wherever you want to pick the file. So I'm sharing my complete screen now. I think otherwise you will not be able to understand what I'm telling you. Give me a second. I'll share my entire screen with all of you. Fine. Now I'll take you through my laptop in screen. You can see presently, I think I am on a particular location. If you can see, it is PC, D drive, academics, RFDP, and workshop, right? In this, if you can see, my file is visible to you, education dog owner. Visible?
Yes, ma'am.
So what I'm telling you, you need to also find the location of your file. Means if you have downloaded your file, it will be maybe in the download or at maybe at some place of your desktop. So you need to find the location of your file. The way I have shown you my file. I'll come here, I'll do the right click on this. I need to do the right click, visible, and I'll go to the properties here. Then in the location, you can see my location is visible to me. I'm copying the location. I have do the control C. I have copied the location. I'm closing it. I'll go back to the R, and in the set WD, inside the double quote, I will paste the location. Done. Done. So it is something like we are telling to the postmaster or post office master that what is the address from where or where you need to deliver the file. But from here, we can say from where you need to pick the file. Right. So this is the location I have set. Visible, clear to everyone? Friends, it is okay?
Yes, ma'am.
Now I'll press Control Enter. You can see in the console I'm getting an error. It is giving me an error saying /A is unrecognized escape in character string. So meaning is that you need to make it double slash. These are the backward slashes, right? So you need to make it double backward slashes, and then you can press Control Enter. Now you can see without any error, this line 655 is executed in the console. I'm not getting any error there, right? That means my directory is not set. From this directory, I need to pick the file. I'll do the, sorry, not here. I'll come here. I'll come back to here. And now I'm giving the name to my object as data. In this particular object, I will store my data. So I need to use read.csv. I need to use this particular function, read.csv. And again, I'll go back and I'll copy the name of my file. And then inside the double quotation, I'll type the name of my file along with its extension. That is education.owner.csv. Done. Done. Those who are not performing, maybe if they wish, they can note down the syntax. Okay. Do I need to wait or shall I go ahead?
Go ahead.
Fine. I'll press Control Enter on line number 657. You can see execution is done. I'm not getting any error. And in my global environment also you can find data object is created. It is showing 20 observations of 4 variables. And with that you can find at the extreme right, the symbol is coming. This is a data frame. I'll click on this. You would be able to see my data. Visible to everyone. Done.
Ma'am, can you please repeat this step?
From where, ma'am?
Uh, from the data, how we show the data, ma'am?
Just a minute. How to use the data? This is what you are asking. Firstly, you what is the page? You need to set the
Yeah, ma'am. These two steps are right under 655 and 657. Both
and
are done.
this when go and
How to see the data in my R?
I'm
That
telling
is
you.
my
Wait,
ask.
I'm telling you. First step
Okay.
is you need to set the working directories. Set WD meaning you set working directory. So you need to set the location from where you want to pick the file. So what I said, I go to my folder where my
Ma'am,
file
that's I done, ma'am. That's I done. Set WDT is also done, and I created data, read dot CSV, all done. I am just asking how the data, now you are selecting the data in R.
Hmm.
How to see the data in R,
Okay,
just
I
that step.
said go to the global environment. In the global environment, if you have created the object data, it is visible to you. And extreme right, icon is coming of the data. So click on that. It is
Yes,
showing
ma'am, I
you.
got it, I got it, I got it.
Fine.
Thank you, ma'am. Thank you.
Thank you. So this way we can see the preview of the data. If data size is very large, what you can do, you can come here and you can type a function head. If you can recall, I told you head is a function which is showing you the first 6 row of your data. You can see visible. Or tail. It is showing you the last 6 rows of your data. Done. Done, friends?
Yes, ma'am.
Fine. So now, if you have seen your data, you can find there is gender, pet ownership, and the education level available in the data. So although my data is already coded, I have done a coding of my data. So I'm telling you, you can do one thing. If you wish, just I'm writing you the codes here because I think you people are not knowing what is the meaning. One is for male, two is for female in the gender. In the pet owner, 1 and 0. 1 is for yes, the person is owning the pet, and 0 meaning is person is not owning the pet. Third one is education. Education 1, sorry. In education, 1 is meaning person is undergraduated. 2 meaning is person is postgraduated, and 3 meaning is other. Right? These are the meanings of these 1201, 123 in the data. Is it clear now?
Yes, ma'am.
Fine. Now, if this is the thing like this, now you need to firstly decide upon as I'm going for the second kind of chi-square test, that is the test of association. So I am selecting the 2 variables out of these 3. I'm selecting the gender and pet ownership here. So I will make my hypothesis like there is no association between pet ownership, pet owner status, and graduation status. No, and gender. Or I can say Pet ownership is independent of gender. If you will read both the statements, both are saying the similar meaning. There is no association between pet ownership and gender, or you can say pet ownership is independent of gender. Fine. Hypothesis is clear. Trends. Hypothesis is clear.
Yes, ma'am, it is clear.
Fine. So as both are the categorical variable, we will go to perform chi-square dot test, right? And then what you need to do, you need to provide the variable. So how you can pick the variable from your data frame? Other way is you can use the dollar sign and you can select your variable. So I'm selecting this data dollar gender. Done. Done.
Yes, ma'am.
Now press Control Enter. You can see you are getting the output. I'm copying it. This is my output. Now chi-square what I got is 0.87912. Degrees of freedom is 1. P value is 0.3484. So if I will look at my P value, what is the meaning? P value is, if suppose level of significance was 5%. So please compare and tell me what is the meaning here.
Ma'am, please repeat.
Okay, I'm asking P value is 0.3484, right? So if this is a P value and your level of significance is 5%, at 5% you are testing your hypothesis. So what conclusion I will draw?
You should reject null hypothesis.
We should reject the null hypothesis.
Ma'am, because P is less than level of significance.
So P is greater than. It is 0.34, 34%, and our level of significance is 5%.
Yes, ma'am. I thought 0.5. Sorry, ma'am.
Yeah, it's not 0.5, it's 0.05%, not 50%, right? So we
Yeah,
can,
got
yeah,
it.
yeah. So we can say accept the null hypothesis. So what we will say there is no association between pet ownership and gender. Means there is no role of gender in deciding the pet ownership of a person, whether a person is male, female. It is not making any impact on the pet ownership, right? Pet ownership is independent of gender. Is it okay?
Yes, ma'am.
Okay, what about Asna ma'am? You got it?
Yes, ma'am, I got it.
Fine. Interpretation is also clear?
Yes, ma'am.
Fine. Now, in the same data, one more variable is available, which is education. So may I expect from you people, those who are performing, that can you perform the chi-square test on pet ownership and education and can tell me whether there is any association between pet ownership and education? Please perform and tell me what values you are getting.
Okay, ma'am.
Yeah.
Ma'am,
Yeah.
chi-square is 3.2967.
Mhm.
Level of DF2 p-value is 0.1924.
0.1924.
0.192,
0.1924. Okay. So in that case, what decision you will make?
which is greater than 0.05. So accept that.
We are accepting the null hypothesis. That means what we are saying, there is no association between pet ownership and education.
Education.
Even education level is not helping you to deciding whether the person is pet owner or not. Right?
Yes, ma'am. Yes, ma'am.
Right. Thank you so much. Thank you so much, ma'am. So this way, this was the second kind of chi-square test. Right? Now, may I give you some exercise today if you can perform? I don't know, Miss. I think Asta ma'am and Hari sir is talking and probably they are performing. What about the others? I'm not getting. So, do I need to give you one exercise here to perform?
Ma'am, I have a question here.
Yeah.
Ma'am, how we decide the level of significance?
Sir, usually it is depending upon the discipline or domain you are. Because as I said, I belong to the management side, social science side, social field. It is a social science domain or discipline. So where generally there is no matter of life and death, right? So if I'm keeping the error percent as 5, it is fine. And as I told you, if the level of significance is very high, that means reliability is very less. That is the one thing. Second thing is, suppose my research is belonging to the medical side. In the medical field, generally, whatever tests or whatever medicines are generally produced or manufactured or maybe tested by the scientists and all, they cannot take the level of significance this much high because there is a case of life and death, right? So in the field, in that field, that person should be very less. So it is totally depending upon in which field you are doing your research. In social sciences like engineering, etc., we can go with this percent. 10%, 1% is 1%, 5% is okay, right? So depending upon in which field we are conducting the study, that way we are deciding our percent of that error. What will be the percent of error are permissible there? Fine, Hari sir.
Yes, ma'am. Thank you.
Yeah. So shall I go and give you one more exercise here to perform? Anyone?
Okay, ma'am.
Fine. I have given you a
Can,
problem. Fine.
can you please enter the question and the data into the WhatsApp group?
Sorry, again repeat.
Can you please give the data and the question to the WhatsApp group?
Ma'am, the problem which I have given you, for that I have not provided you any, I'm not providing you any data. I have only written the
Or the
problem.
same data?
No, no. For this, you need to make your what vectors.
Oh, okay, ma'am.
So I am
I'll
telling.
try, ma'am.
Yeah,
I
yeah.
don't know whether it is getting or not, but I will try.
Fine.
Okay.
Now you can see I created one vector. I have given you the problem. Problem is whether the smoking habit is independent of gender. So two variables are there. Yes. Smoking habit and gender. So I created first vector which is for gender. So I have used ref function which we have already seen on day 2, I guess, right? And here I have used it, which is creating or helping me to create the vector of 10 people, 20 people, 10 male, 10 female. Is it okay?
Yes, ma'am.
Then for smoking habit, sorry, rather than using ref function, I will write like this. Is it okay? What I did is clear. I have created two vectors, one for the gender, second for the smoking habit. Gender I have created using the rep function, but smoking habit deliberately I have not created and using the rep function because it will be n by n likewise. So what I did, I have created it like this, right? In both there are 20 observations. Fine. Now you can see I have used a table function to see the what I can say contingency table. You can find gender, female, male, smoking habit, no, and yes. So 7 female are saying no, 3 are saying yes, 5 male are saying no, 5 males are saying yes. Is it clear?
Yes, ma'am.
Now I need to perform chi-square test. So we have performed chi-square test. You can find. Anyone who can help me to conclude? Is it okay?
Yes, ma'am. Here again, p-value is greater than level of significance.
Very good. So what conclusion we will draw? We will accept the null hypothesis.
Yes, ma'am.
What will be that?
Accept null hypothesis.
Yes, what will be that? There is no association between smoking habit and gender, right? Gender is not playing any role in deciding the smoking habit of the person, right? Is it okay? Asna ma'am, are you understanding? Yes, yes, Hari sir. What about Asna ma'am?
Yes, ma'am, I'm just doing that.
I'm waiting. You please perform and
It's
then
just
tell me.
slow. Can you please show? Okay, ma'am. Just 2 minutes, ma'am. It's
Yeah,
fine.
yeah. I'm
Can
just
you
waiting.
please? Okay, okay.
Just a minute. I'll show you the complete screen. You can see from here I started. Line 667. 677, sorry. So this is for contingency table. This one. Done, ma'am.
Okay, ma'am. Please continue, please.
What are you getting?
There is some error, ma'am. I think I just check the
Can you tell me what is the error you are getting?
in table gender smoking. All the argument must have the same length.
That means your length of the vectors is not same. You whatever vector you have created, suppose for gender, if you have created, check its length, ma'am.
Okay, ma'am.
Right?
I just
Similarly, for both the vectors, you check the length. It should be 2020. In my case, it should be 2020. According to your data, you need to decide the length should be same.
again.
For gender, what is
All
it?
arguments are the same.
For gender, it is
I just okay. Length should be 20.
gender is 20. Smoking habit is
Uh, 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 length gender is 40. Oh, great.
it's 40 or 10, 10.
40, man. I just
40.
checking.
It's 40. So in that case, smoking habit should also be entered 40 times. If 40 people data is there in the gender, 40 people's smoking habit should be there for with you, right? So the size of the second vector should also be 40. There should be total 40 observations. Getting me?
There is only 20 observation, ma'am, but whenever I write the 20,
So
I
my
don't get the.
smoking habit is 20.
Yes, ma'am.
So that is,
MFM is like 20, male, female. And the
and
gender, वहाँ पर भी मैं CMF20 लिखती है, but I don't know what is the problem.
according to what you told me, according to your error, it is a problem of the length of your vector. So in the gender, as you can see, I have taken because it is times. 10 is what times. So M will be 10 times, F will be 10 times, right?
Yes,
Similarly,
ma'am.
smoking habit I have taken, I have entered total 20 values here. So 20 times means it is combination of Y and N and 20 figures I have entered here. And I have checked the length, it is coming as 20.
First, it should be 20. It is 20, ma'am.
For both the
But
vectors, it should be 20. It is 20 for both the vectors.
no, ma'am.
For gender, it is the
I
same way
think
you created your gender vector, ma'am. REPCMF 10.
yes. I think there is missing one bracket, ma'am.
That is why.
Okay, ma'am. I will do it.
Okay.
Again, it is showing that there is an error. It's okay, ma'am. I will do it. This.
So if you can share on the WhatsApp group, I will check.
Sorry, ma'am. I am just doing it two devices, so I don't.
No, you can take a pic and share on WhatsApp group, ma'am.
Okay, ma'am. Just a minute.
Shared.
Just minutes, ma'am.
Yeah.
How may I do it? Can you please check it?
Yeah, I'm just looking at it. Okay, ma'am, before, once you have created the vector gender, you started with the bracket. REP will not come inside the bracket. Remove it first. And bracket also need to remove. You need to write REP, bracket open, C, bracket open, M and F in the double single quote or double quote, bracket close, 10. And then again bracket close. That's all. You did it?
Ma'am, I think I'm forward to write factor.
It is fine. If you are not means, I have converted because gender is a categorical variable, so that is why I did. If you wish to make it a factor, you can do this. If not, without that also you can perform. So if you wish to add factor, then that case it is okay. Second mistake what you have made is, second mistake is that in the smoking habit, instead of why and yes, no, means why means yes, no means no, means whether the people are smoking or no. You have used MF, MF, MF. That is the error you made.
Oh, okay, ma'am.
It should
So,
be by n. And one more thing, y and what you have written should not be same. If you are writing y and n similar, so in that case, once you will make your contingency table, it will give you 5, 5. So that is not correct. So what I have done, randomly somewhere I have written y, somewhere I have written n. You can see 1 time y, 3 times n, then 2 times y, 1 time n, then y, then 3 times n. So that way you need to make a combination.
okay, ma'am.
And one more thing, I think C which you have written in case of a smoking habit is a capital C. It should be small c. Getting?
Okay, ma'am. Okay.
Check out whether it is small c or capital C. If it is small, it is okay, but it is okay. Remaining mistake I told you.
Yes, ma'am. It is small c.
Fine. In table gender smoking or all the arguments must have the same length. So you have checked the length of gender, means the length of smoking habit also. Like the length of smoking habit also. What is the length of a smoking
Just a
habit?
minute, ma'am.
Yeah. Then what is the length? Have you checked?
Yes, ma'am. The length is 20.
It is 20.
Yes, ma'am.
Okay. So if it is 20, I don't think it should be any. It should give you any error. Because according to your error, it is the problem of length of the vectors.
Okay, ma'am.
So after doing all these corrections, now it is okay.
1 minute, ma'am. Just 1 minute.
I am waiting. Complete it.
You can proceed, ma'am. No problem.
No. I think we should do that. I think you and this are only.
Now, ma'am, thank you, ma'am. Now it is okay.
Fine. Thank you.
Thank you, ma'am. Thank you.
So much, ma'am. Fine. So if ma'am has got, Hari sir has got, it is okay. Fine. So I think we have completed chi-square test today. So I'll go for the conclusion of the session, and then tomorrow, I think it's Sunday, probably there will be no session. We will meet on Monday for the next session, right? So I'll conclude today's session. Today we have talked about non-parametric tests. That means we have moved to the inferential statistics, and now onwards I started with the non-parametric tests. I told you non-parametric tests are the tests which are not bothering or considering the normal distribution of the data. These are based on the categorical data. That means we need to have the count or frequency of the data for performing the non-parametric test. So there are so many non-parametric tests are available. We started with the chi-square test. And I told you chi-square test purpose is to check the uniformity of the frequencies, whether the frequencies are equally distributed for all the categories or not. This is the basic purpose of the chi-square test. There are two types of chi-square test: goodness of fit and independence of attributes. Goodness of fit is we are performing when we are having single categorical variable with its multiple categories. So we are willingly, or we want to see here whether all the frequencies are equally distributed in all the categories of the categorical variable or not. So to check the uniformity of the frequency of the categories of the variable, we want to perform chi-square test. The simple hypothesis which we are making is there is no significant difference in the observed and the expected frequencies, right? Chi-square dot test function, a very simple function we will use here, and we need to pass the vector of the observed frequency, and then we need to define the p-value, that is probability value, using the expected values or expected vector. And that way, I think we will go for the getting the output and go for the interpretation of the data. Then we have understood the second chi-square test, which is the test of association and dependence of attributes. So we want to see whether the two attributes are related to each other, whether these two attributes are associated or whether they are independent of each other. So that means we will be having two categorical variable, and we will make the contingency table here to see the frequency distribution using the table function in the R, right? And simple hypothesis we are making, there is no association between the two categorical variables. And again, using the chi-square dot test function we will use, and we will pass on the categorical variables inside this, and we'll get the chi-square value. Interpretation will be based on the p-value approach, which says if your p-value is less than level of significance, you will reject the null hypothesis, and opposite to this, if p-value is greater than level of significance, we will accept the null hypothesis. So friends, this was about the chi-square test from my side for the day. Now we will be having the next session on the parametric tests, right? So in the next class, in the next session, we will talk about the parametric tests. So this is all from my side for the day. If you are having query, you can ask. Queries are welcome. If not, we can end the session for the day.
Ma'am, could you briefly explain about the degree of freedom, the term, what it says?
Yeah. Degrees of freedom is, sir, how many degrees are free to take any value. Say, for example, if suppose I'm having that color variable, right? So I think 5 colors I have taken. So meaning is that if I'm having 5 colors or 5 categories, so out of 5 categories, the degrees of freedom is n minus 1. That means 4 categories are free to accept any value. So if I want to make it more easier for you, I can say, if suppose there is a bus, in that bus there are 5 seats available, right? 5 people are entering into the bus. So the first person who will enter, he or she is having the choices. Out of 5, he can select any of the seat to sit. Second person will reach. Out of 4, he or she can select the next seat, likewise. But the last person who is reaching to the bus or entering to the bus, he is having no choice. Whatever the seat is left, he or she needs to occupy that. So degrees of freedom is similar. If I am saying 5 numbers, or the sum of 5 numbers is suppose 100. So first number can take any value. It can be any value. Similarly, second, 3, 4, and 4 variable. But fifth variable will always be depending upon the sum of the remaining 4, right? So that way we can say degrees of freedom is nothing, but it is telling you the freedom, how many of the categories or values are free to accept any value. right?
Okay, ma'am. Thank you.
Thank you so much, Hari sir. Any other question? Any other question? Fine. So if no more questions, I think we can end the session, right? So thank you, everyone. Yoga sir, we are done for the day. And I think tomorrow, do we have a session or we are meeting on Monday now? Monday. Monday. Okay. So we are meeting on Monday, friends. Thank you so much, everyone. Good night. So we can close and the meeting.